In telecommunication, cable internet access, short to cable internet, is a form of broadband internet access which use the same infrastructure as a cable television, like digital subscriber line and fiber to the promised service. Cable internet access provides network edge connectivity from the internet service provider to a end user. It is integrated into the cable television infrastructure analogously to DSL, which use the existing telephone network. Cable TV networks and telecommunication networks are two predominant forms of residential internet access. Recently, both have seen increased competition from fiber deployment, wireless and mobile network. Broadband cable internet access require a cable modem at the customer premise and a cable modem termination system (CMTS) at a cable operator facility. Typical a cable television hidden. The two are connected via coaxial cable or a hybrid fiber coaxial FFC plan. While access networks are sometimes referred to as last mile technologies, cable internet system can typically operate where the distance between the modem and the termination system is up to 160 kilometers. If the HFC network is large, the cable modem termination system can be grouped into hubs for efficient management. Downstream, the direction towards the user bit rates can be as high as 1 gig. These limits are set in configuration files which are downloaded to the modem using the trivial file transfer protocol. When the modem first established as connection to the provider's equipment, also love telecommunication.
Okay guys, now I will explain about DOCSIS. DOCSIS or Data Over Cable Service Interface Specification is an international telecommunication standard that permits the addition of high-speed data transfer to an existing cable TV system. It means it is employed by many cable television operators to provide internet access over their existing hybrid fiber coaxial infrastructure. In other words, everyone who have fiber to the home service. In reality, that would cost billions of dollars to make happen. On a practical level, DOCSIS matters for consumers because you will have to decide which DOCSIS standard you need when purchasing a modem for your cable internet connection. Depending on the quality of your connection, the answer is not necessarily just the newest one. The history of DOCSIS. The DOCSIS was created in March of 1997. The DOCSIS standard has been through multiple rounds of improvement and iteration since its inception. It was initially developed by Cable in conjunction with a multitude of contributing companies, including Tricoms, Aries, Big Bang Networks, Broadcom, Cisco. As an overarching technology, DOCSIS includes several different pieces of actual hardware. including but not limited to a cable modem located at the user's premise, as well as a cable modem termination system located as well, usually at a cable company and or outside. How the DOCSIS works. Okay, there are two main components of DOCSIS, that is the physical layer and the media access control layer. Now, the physical layer is a bit easier to understand, but it is an important part of how the operation technology actually works to deliver your cable connection to the internet. For instance, the physical layer pertains to the wiring and routing equipment used, as well as the frequency at which data is transmitted through these various physical systems. In general, faster transmission speed means better performance, but there are a few limitations in terms of physical distance that can change this. This distance restriction affect the areas where DOCSIS based cable modems and other infrastructure can be installed, which in turn affect the resulting speed and price. Now, the media access controller (MAC) layer. By contrast, it is designed to intelligently handle the massive amount of information being processed at any given time, allowing for a crucial level of organization that prevents frequent traffic jams caused by signals colliding with one another. Second, continuing the analogy, each device on a network has a MAC address tied to it, which acts as its own personal stoplight in a massive metropolis for other devices, all vying for access to the same information. Why does it matter for me? Because DOCSIS standard your equipment use, you may or may not be able to take advantage of the latest internet speeds offered by your cable internet provider. In certain areas, this may not be an issue, as the speed limitation of the infrastructure may not be able to take advantage of this newer technology. So that is all the meanings of DOCSIS.
Now I want to discuss about an evolution through the years. Uh, there are six DOCSIS version. There are 1.0, 1.1, 2.0, 3.0, 3.1, and 4.0. The first one is 1.0. Production date is 1997. Maximum downstream capacity 40 megabytes per second. Maximum upstream capacity 10 megabytes per second. The future is initial release. Next is 1.1 version. Production date is 2001 years. Maximum downstream capacity 40 megabytes per second. Maximum upstream capacity 10 megabytes per second. The features is at VoIP capabilities, standardize the DOCSIS 1.0 QoS mechanism. Next is 2.0. Production date is 2002. Maximum downstream capacity 40 megabytes per second. Maximum upstream capacity 30 megabytes per second. The features is enhanced upstream data rates. Next is 3.0. Production date 2006. Maximum downstream capacity 1.2 gigabytes per second. maximum upstream capacity 2000 megabytes per second. Features is significantly increased downstream or upstream data rates, introduce support for IPv6, introduce channel bonding. Next is 3.1. Production date is 2013. Maximum downstream capacity 10 gigabytes per second. Maximum upstream capacity 1 to 2 gigabytes per second. Features significantly increase downstream upstream data rates, structure channel specification. And lastly is 4.0 version. Production date is 2017. Maximum downstream capacity 10 gigabytes per second. Maximum upstream capacity 10 gigabytes per second. The feature is introduced support for fully symmetrical speed.
What is the latest DOCSIS standard? In 2013, DOCSIS 3.1 was released, bringing with another massive leap in the both up and downstream speeds. This introduction brought the cap to 10 gigabytes for download speed and 1 gigabyte for upload speed. Today, work is already underway to develop a new interaction commonly referred to as DOCSIS 4.0, which was released in 2017. This version, when released, will bring support for symmetrical down and up speed of 10 gigabytes, allowing upload speeds to catch up to down speed for a first time since DOCSIS inception. Looking to the future, as time marches onward and the rate of technology progression only seems to accelerate, it is inevitable that DOCSIS will continue to evolve to accommodate new service technologies and demands from users all over the world. As informed consumers, it is our task to stay up to date with this change in order to determine which one might benefit us the most. As 4K and UHD video become increasingly common and the both wireless and wired network increase in terms of scope and convenience, it's probably fair to assume that there are plenty of exciting developments still yet to be made to the specification over the coming decades. Packet cable. Packet cable is a technology specification defined by the industry consume cable labs for using Internet Protocol network to deliver multimedia service, such as IP telephony, conferencing, and interactive gaming on the cable television infrastructure. The packet cable technology is based on the DOCSIS-based reach extension that enable cable operator to deliver data and voice traffic effectively using a single high-speed, quality of service enabled broadband architecture. The original packet cable specification were based on the physical network characteristic of operation in the US for the Europe market. Cable Europe Labs maintained separate but equivalent effort Euro packet cable based on Europe network implementations. Protocol in packet cable. DOCSIS Data over Cable Service Interface Specification, a standard for data over cable and details mostly the RF band. Real-Time Transport Protocol (RTP) and Real-Time Control Protocol (RTCP) require for media transfer. PSTN Gateway Call Signaling Protocol Specification (TGCP), which is an MGCP. extension for media gateway. Network-based call signaling protocol specification (NCS), which is NMGCP extension for analog residential media gateway. The NCS specification, which is derived from the IETF MGCP RFC 2705 detailed 4P signaling. Basically, the IETF version is a subset of the NCS version. The packet cable group has defined more message and features than the IETF. Command Open Policy Service (COPS) for quality of service.
Hello guys. Okay, firstly, I will explain about Packet Cable 1.0. Packet Cable 1.0 comprises 11 specifications and 6 technical reports which define call signaling, quality of service, coded usage, client provisioning, and billing event message collection, public switch telephone network (PSTN) interconnection, and security interface for implement a single zone packet cable solution for residential internet protocol voice service. And next, packet cable 1.5. Packet cable 1.5 contain additional capabilities over packet cable 1.0. It superseded previous version 1.1, 1.2, and 1.3. The standard cover 21 specifications and 1 technical report, which together define call signaling, quality of service, coder, client provisioning, billing event message collection, PSTN interconnection, and a security interface for implementing a single zone or multi-zone packet cable solution for residential internet protocol voice service. And next, packet cable 2.0. Version 2.0 introduced IMS, release 7 IP multimedia subsystem into the core of the architecture. Packet cable uses simplified IMS in some areas and ancients in some cable-specific areas. Packet cable defines data specs related to the most important IMS spec from 3GPP. Okay guys, firstly, this is packet cable network architecture. Uh, this is managed IP network in the center, and this is application manager, the application server, and this is IP based network, and this is media gateway, signaling gateway, and PSTN/ISDN. Okay, in this left, this is HFC access network, DOCSIS. And this is CMTS. FLC FFC access network, DOCSIS, and this is CMTS. This is policy server. Okay, CMTS means cable modem termination system. This is CMTS. Okay, this DOCSIS. DOCSIS is data over cable service interface specification. In this DOCSIS, okay, HFC hybrid fiber coaxial. Hybrid fiber coaxial in the FFC access network. Okay, FSS FSS means home subscriber server. In this cloud, okay, this
HSS. And next, ISDN. ISDN is mean Integrate Services Digital Network. In this, and PSTN, Public Switched Telephone Network. Together with ISDN. Okay, thank you.